All right, let's jump right in. We are looking at what might be one of the most mind-bending astronomical events of the decade. It's an interstellar comet, a visitor from another star system named 3I Atlas. But here's the thing, this is no ordinary comet. It's doing something that, well, according to everything we know about physics, it just shouldn't be able to do. And the whole mystery? It starts with its tail.
Seriously, just let that sink in for a second. Astronomers are looking at this thing, they're running all the numbers, they're checking their models again and again, and they keep coming back to the same impossible conclusion. What we're seeing just doesn't add up. So what on earth is going on here?
So our story, our investigation, it really begins with a truly bizarre observation. I mean, we all know how comets work, right? The tail always points away from the sun, pushed back by solar wind and radiation. But 3I Atlas, well, it has a second tail, a sharp, brilliant line of light pointing directly into the sun.
And what's so incredible about this is that this whole scientific firestorm wasn't kicked off by some giant billion-dollar observatory. No, it was an amateur observer, Kalapa Stars, looking up from the beautiful dark skies of Hawaii. They used a smart telescope with some pretty slick AI processing and captured this stunningly clear image of a razor-thin anti-tail. This wasn't some blurry smudge in the sky, it was a definite, coherent structure that threw a huge wrench in everything we thought we knew.
Now you might be thinking, hang on, don't some comets have anti-tails? And you know what? You'd be absolutely right. They do. But, and this is a huge but, the tail on 3I Atlas is completely different from any we have ever seen before. Let's break down exactly why.
So a typical anti-tail, it's not really a tail in the way you'd think. It's actually an optical illusion. The best way to picture it is like a trail of breadcrumbs, heavier dust particles that the comet leaves behind in its path. When Earth happens to pass through that exact orbital plane, our specific line of sight can make that dust trail look like it's pointing at the sun. It's all just a trick of geometry.
And this is where the standard explanation just completely falls apart. A normal anti-tail, the illusion, is this broad, fuzzy fan of dust that disappears pretty quickly. But look at 3I Atlas. It's a razor-thin, highly focused beam. It's been incredibly stable for a long time. And the most baffling part? It stays perfectly straight, even though it's being blasted by the solar wind. The geometry argument just doesn't work here. Not even close.
Okay, so if it's not an illusion, then what is it? This is where the real cosmic detective work kicks in. Scientists started scrambling to gather every scrap of data they could find, and honestly, the clues they uncovered only made this mystery even weirder.
Let's look at the evidence file. First up, uniformity. For that tail to be so sharp, the particles inside it have to be almost exactly the same size. Nature almost never does that. Then there's the paradox of what it's made of. It's super bright, which screams reflective ice. But to stand up to the solar wind like it does, those same particles have to be heavy, dense, like metal. And to top it all off, the comet's core is tiny, but way more active than it should be, and it seems to be pushing itself sideways with some kind of mysterious thrust. It's a genuine cosmic puzzle box.
When you have a set of clues this strange, you just know the theories are going to be wild. And right now, the scientific community is pretty much split between a few very, very different ideas.
Okay, so in one corner you have the mainstream theories trying to explain this with some new but still natural physics. One idea is that maybe 3I Atlas isn't a comet at all, but the magnetic core of a planet that got destroyed, and it's using its magnetic field to line up all that dust. Another idea, it's a big chunk of metal from a cosmic collision. But probably the most popular theory right now is a kind of hybrid, a core made of little iron pebbles that are frozen inside a shell of ice. That could explain both the brightness and the density.
And then you have the other camp. Some researchers, most famously Avi Loeb, have pointed out that the kind of uniformity and stability we're seeing here is just, well, it's almost unheard of in nature. They've put forward this really provocative minority view that we can't completely rule out the possibility that we're looking at something, well, something not natural. Now, to be clear, most scientists are betting on a natural explanation, but this fringe idea is forcing everyone to bring their A-game and prove their case beyond any doubt.
The amazing thing is, this isn't just some debate that's going to last for years. We are on a ticking clock. We are on the verge of getting a real answer, because the comet is getting closer to the sun and our view of it is changing every single day. And this is all happening right now. That amazing image from Hawaii, that's our baseline. In early December, some of our most powerful spectrometers are going to be pointed right at that tail to figure out its chemical recipe. And then the grand finale.
is December 19th. That's when the comet makes its closest, hottest flyby the sun. It's a moment that could crack this whole mystery wide open.
And it really all comes down to two simple but brilliant tests. First, the geometry test. As our planet moves in its orbit, our angle for viewing the comet changes. So if the tail is just an illusion, it should start to blur, widen out, and fade away. But if it stays razor sharp, that proves it's a real physical thing. Second, the spectrum test. We can analyze the light coming from the tail and get a chemical fingerprint. Is it made of iron, ice, rock? The spectrum will tell us the truth.
So this is the fundamental question, the one that has astronomers on the edge of their seats. Are we just witnessing a 1 in a billion fluke, a perfect geometric alignment, creating an unbelievable illusion? Or are we seeing a real object that's going to force us to literally rewrite the textbooks on how comets even work? So let's just pull back for a second. Let's look at the big picture. Because no matter what the answer turns out to be, the implications are absolutely massive, and we have to remember the single most important fact about this object. This thing is not from around here. It was born in another solar system, around another star. It traveled through the deep, dark void of interstellar space for maybe millions of years, and now it's just passing through our neighborhood for a short visit. It is a messenger from another world.
So why does this one comet matter so much? Because we're literally looking at a geological sample from an alien planetary system. Whatever it's made of, iron, ice, something else, it tells us what planets around other stars are made of. Its weirdness might even be a clue to a violent past in its home system, like a planet being ripped to shreds. And hey, no matter what happens, this whole debate is pushing our understanding of physics to new places. It's a win-win.
And, maybe the most beautiful part of this whole story is that it represents a new era of science. That old line between the billion-dollar observatories and the backyard astronomers, it's getting blurrier. Data is being shared openly. You've got amateurs like Kalapa Stars providing mission-critical data that the pros at NASA are actually using to point the James Webb Space Telescope. Science is happening out in the open in real time for all of us to see. And that just leaves us with one last thought to chew on. For centuries, we have stared up at the sky. But this comet is a powerful reminder that even the things we think we know can hold deep, profound secrets. It just makes you wonder, what other impossible things are out there, hiding in plain sight, just waiting for someone with a curious eye to look up and find them?